the typical interception problems, what you have to do is write an equation of motion for each object. In this case, a speeding car is traveling at a constant velocity of 30 meters per second, while a police is moving at a constant acceleration of 2 meters per second squared. For these types of problem, what you have to do is write an equation of motion for each object. In this case, the general form for the and the position as a function of time for the police is given by this equation. Now, we can simplify it because the initial velocity of the police is 0, and we'll also set the initial position of the police as 0. So that simplifies itself to this equation. Now we can do the same thing for the speeder. So we'll first write out the general equation, and we'll simplify it by removing the initial position, which was 0, and we'll remove the acceleration term because that's 0 as well. So when the two meet, they're basically at the same position. So the position of the police is equal to the position of the speeder. We'll replace each of those positions with their expressions. Now we can cancel out a t on one side and a t on the other side, and isolate time gives us this equation. We sub in our variables, so 30 meters per second is the initial velocity of the speeder, and 2 meters per second squared is the acceleration of the police. So we have a time they both meet at after traveling 30 seconds. To get the position where they meet, you simply take either the equation for the speeder or the equation of motion for the police. In this case, the equation of motion for the speeder is the simpler one, and we substitute our variables. So 30 meters per second times 30 seconds is equal to 900 meters. So they'll meet after traveling 30 seconds and after traveling 900 meters.